Hello and welcome to Sign for Uncut, a podcast for developers about building great products. Today, I'm excited to welcome Llewellyn Falco. Llewellyn, thank you so much for joining us.
Good morning. It's great to be here.
Great. Can you just go ahead and introduce yourself?
Sure. So I got started back programming. My mother was a programmer, and so I sort of grew up programming. And then very early, I started pairing. I actually created something called strong style pairing, which at the time was just the way I interpreted pairing to be. But the basic idea is that rather than the person at the keyboard doing the thinking, the person who's not the keyboard is doing the thinking. So sort of all ideas have to go from your head to the keyboard through someone else's hands. And that was a really great way to start, right? Because it got me started with extreme programming practices, got me into continuous integration, got me into refactoring, patterns, and got me into unit testing. And from that and through pairing, I created something called ApprovalTests, which is sort of a snapshot library. It's in 12 different languages because, again, pairing makes it really easy to switch and work in different languages. And then from that, I got introduced to coding dojos and rendoris. And I took that back with my friend Woody Zool, and we modified it to be strong style coding dojos, which eventually turned into mob programming when he was working out at Hunter. So approval test and mob programming is what brought me into coaching, right? Because mob programming is sort of a superpower when you are trying to spread knowledge. So I've been doing like training classes with a company called Developmentor, and then I started just coaching teams. And it's that coaching style and the fact that I had a client that allowed me to do a visiting coach program that let me bring in a whole bunch of really wonderful, talented coaches, one of which was Emily Bosch, who was on your podcast a little bit, talked about the salmon method, which is the name she gave for that style of coaching. So that's sort of my history that brings me to you.
Great. And as you were talking about this, I was trying to put some timestamps along the way. So it was like from 90s.
2002 is when I got extreme programming. I went to my first user group. I love user groups. Even like today in the pandemic, when like user groups shut down, and conferences have been really challenging online. I haven't really enjoyed them as much, but user groups have still been great, right? And so there's a couple of user groups scattered across the globe, and now they have like amazing speakers, right? Like one group I really enjoy is the Calgary Software Club in Canada, and Calgary is way in the middle of nowhere in Canada. And so like it would be really hard to go there for a user group. But now that everything's online, just they have amazing speakers. And so I really like meetups. And I went to one early on, as was the Java user group. And that introduced me to the extreme programming user group. And it was my first meeting in extreme programming where I heard someone talk. This was at T-Mobile, which is like a phone company out here. And he's like, it was like 40,000 lines of code. And I got it down to 30,000 lines of code. And I think if I had a little more time, I could have gotten it down to 25,000. I never in my entire life heard of anybody talk about success in removing code. It was just eye-opening to me. I was like, oh, yeah, simplifying a thing could be bringing value to it.
Exactly. Yeah. I found something very interesting. At some point in my life, my father bought me a Volkswagen Beetle,
Yeah.
That's from like kind of 60s look.
I lived in San Diego, like this land of Beatles.
And I ended up reading, some technical stuff about it. And there was a mention about the number of moving parts that the engine has. And I don't have a reference point, what a good, what a bad number is. But I remember that they sounded like very proud. It was maybe something around 900 moving parts. And that is directly correlated to reliability.
Yeah, less moving parts, less things go wrong. And when something does go wrong, easier to fix. Like, I think that's a big part of Agile to me, is not that things are solid and never break. It's that when we make mistakes, they're just so cheap. They're so cheap, people don't even realize we're making them.
Yeah. And from all the things that you have mentioned, one of your creations that are only yours, of course, is approval testing. So that maybe shines in that because it's unique, and I would love to hear more about it. So if you can give us a background.
One of the things that I noticed was very different about the way that I write tests is that I would often go to the whiteboard. And if you look like arrange, act, assert, you might notice are sort of the same things with different words. A lot of times people struggle putting those tests together. What I found I would do is I would just write like my story in whatever form it did. Like there was a time we were out at a company, this is in the Netherlands, and we're writing software that would calculate how an arm would swing around, like a camera swinging around a person. So there's a lot of like sort of 3D transformations, and it was very hard when I took the team to the whiteboard. It was really hard to get us to write that story until like someone just literally picked up a pencil and was like rotating around to me, like, look, the eraser is the camera. Look at how that, and all of a sudden, like we all could get on the same page, and then we could write it on the board. And once we write on the board, we can write it into code. I'm a huge believer in just get agreement on what the story is. But when you do that, you often end up with something where it's like, okay, well, I have the arm and it's here, and then I'm going to swing it around here. And I need to make sure that the path follows this. And that's really hard to assert on, right? Like that path has a lot of different points. Do I just pick the 1 point? Do I pick, 10 points? Like, what do I really care about? Well, I care about the path. Like, I want that path, right? And so, what approval tests allowed me to do is say, I want to verify the path. And what you would do is you would capture that, and you have to serialize it in some way. But there's lots of different ways you can serialize a path. And one could just be like a list of points, right? Like, hey, it's going to follow all these points. And then how do I know that this path is right? Well, maybe I pull that file out into Excel and actually like graph it some way. But I need some way to know that it's changed. And at the time, I was a Windows user. So back when I would build my own computers, Windows was just such a delightful OS. I've been on Mac for a while now and I really like it, but I've never custom created a Mac. You buy it, it's in the box, you open it, it's like, that's it. But with PCs, like you would go to the store and you would figure out your case and your motherboard and your graphics cards. And it was really a nice way to do it. And it was a good way to do it too, because, I was poor. And so like I didn't have a lot of money, and being able to get a computer that really worked, like I had to sort of put it together myself. And so on Windows, there's this wonderful program called SlickRun. And SlickRun was this very simple little program that just sort of sat in the corner. It had a keystroke that would allow you to get to it. And then you could type a command and it would open a program for you, right? And this launcher is really powerful, right? You would start is just like, oh, I can just from my keyboard, I can open Chrome or I can open Word. But then like over time, you'd be like, in the morning, I want to like check my mail and, open up the news. So you'd start writing commands that would open like three things. I would pair program on ApprovalTests in C++ with Claire McRae, who's a very talented C++ programmer out of the UK. And she had a SlickRun program called Llewellyn. And like when we would start, it would like resize her screen and set her microphone and, like do everything that was needed for us to do a pairing session. And so like SlickRun sort of introduced me to this idea that there is a lot of power, not in doing things yourself, but just in harnessing the power of other applications. So once I could capture this to a file, like I wanted to open it in a diff tool. I wanted to open it in Excel. Okay, I got the result of this process. How do I see that this is what I actually care about? And then when it changes, how do I see how it changed? Statement of like, show the data, show the difference. And different programs could show me the data and different programs could show me the difference. And I wanted a way from my unit test to easily be able to see either of those based on where I was. And so that's basically what approval test does. It's not a very complicated thing, and it sits underneath your testing framework, right? So like if you're using the Java version, you're probably using NUnit. You're using the .NET version, you might be using NUnit. If you're using the Java version, you're probably using JUnit. So it sits under JUnit, but at the point where you would normally say like assert, like path point 3 equals, 5.4, whatever. Here you just say verify the path, and then it serializes that to a file, And then it opens it in some other program that will let you say like, hey, is this what I actually want? And it's very easy to recognize that I got what I want, but it can be very hard to define I got what I want. So once you recognize it, you just move that file over and then it doesn't bother you again unless stuff breaks, right? Because you have like 900 tests. You don't want to see all 900 things. That's the whole point of automated tests is it doesn't bug you when stuff works, right? It just nicely says, hey, stuff is working. But then when something goes wrong, it will open it up and it will open it up in really powerful programmers like diff programmers programs that can be like, lines 5, 6, and 93 are different. And you can look at it and be like, oh, I understand what I did wrong. Or you can look at it and be like, no, those are now what I actually want, right? Because you get both things with test breaking. And one of the things that people talk about usually when they test badly is, oh, I wanted to change the code, but all my tests broke, even though the code is still working. That's a horrible thing because tests lock behavior. And so often we inadvertently lock the implementation instead of the result. And so it's like, I'm getting the right result, but my tests are breaking. Now my tests are hurting me. That's the opposite of what tests are supposed to do. So making it very easy to be like, no, what I want to do has now changed. Let me just hit a button and say, yes, this new stuff is actually what I want. That's really powerful.
Microservices architecture is all the rage these days. But do you know what it really means and how to implement it to empower your teams to make the best decision for the problem at hand? On the Semaphore blog, you can learn about microservices and how to take advantage of features like test reports, monorepo, and Docker support to build, test, and deploy your microservice application at scale. Head over to semaphoreCI.com/blog for more information. And happy reading!
As you were explaining this, and you were mentioning a test suite which is in a way fragile.
Yeah.
What are some, experiences that you had with large or, kind of legacy test suite which end up being very big? To give a bit of a background to this, so to us, our biggest clients are usually our most interesting clients because they are pushing us, by sometimes nice, sometimes very weird challenges that they are facing. But usually with their success also has been generated a huge test suite. Potentially a legacy application is what they are also dragging, and carrying on their back, and they are marching towards some a bit brighter future. And there are a lot of tests that have been written by some people potentially 10 years ago that have to be maintained and so on. So it's a very tricky situation. Majority of people hope that they are going to get out of that situation somehow.
A lot of people hope they're going to get out of that situation through some sort of bankruptcy. They're like, every day I'm getting deeper and deeper in debt, but there's going to be this place where eventually it like just disappears. And that's just not how the world works.
Yeah, exactly. By doing this podcast, I ended up having a hobby, like hearing war stories of working on such projects.
So the first thing I want to talk about is just like Emily Bosch does some absolutely amazing katas for legacy code, right? Like the most famous one is Gilded Rose, but she has a whole bunch if you check out her repo. And very often, like I will use those, but sometimes I want to do like a talk or an exercise in just some bad code. And the thing is, I can go to almost any company and just randomly drop into a section of code and be like, oh, great, this is a good example of some code that needs some love. That needs to be cleaned up. But for some reason, when I would look around in GitHub, I had a very hard time finding any of this. And my initial thought was like, well, it's open source programmers. They're doing it in their spare time. They obviously have like some passion around this. Maybe they're just good programmers who don't write that kind of code. I don't believe that anymore because I eventually figured out how to find the really bad code on GitHub. And the answer is like, you need to find the really popular projects, right? Like go look at Apache. Like Apache has some horrible code in it. Why? Because when you write open source, you don't get paid for it, right? So why would you do something you don't get paid for? And the answer is because it's fun. And the moment that the software starts to become a little bit not fun, those projects get abandoned, right? And be like, okay, well, I'm stopped. But that is not the case in a company. In a company, that project becomes unfun and people continue to work on it for decades. Because fun is not like something that is a requirement in a company. I find that really unfortunate. I believe joy should be paid way more attention to, right? And there's some very interesting stories around joy, especially for Stack Overflow being an interesting one, right? Like Stack Overflow came out of the company just caring about developers being happy on what they worked on, and they weren't happy on the bug tracking system they were on. So they were like, well, go do something that will make you happy. And like, so this value in following bliss. But there's also, stuff needs to work at your company, and very often like it gets bad. So that's why I think like when you say those big companies, well, those are the companies that have been around the longest, have had like the most programmers. They're the companies that have continued to work in a project that wasn't fun, and they put the most money, effort, and time into it. And that's why they are so challenging. You can't just delete them because those systems are great and they're making a lot of money, right? Like Woody has a saying of like, respect the code, right? Like nobody's trying to make a bad system. They're trying to do the best they can with the pressure and the constraints. And this is just like what they know. And that's why it's so important to make space to increase your capacity. Very few companies do this. They're usually trapped in the urgent, right? Even companies that have been around for decades and will continue to be around for decades feel like, well, I got to get this done by the week or, life will end. It's not the case. And they keep digging deeper. But in these situations, we end up with a lot of very interesting code. And you're right. Often there are test suites. Often those test suites are very slow, not very informative. And also, I don't want to say like the tests are unreliable. I've definitely seen places where their tests are unreliable, but in most places they now have like some sort of continuous integration and the tests are reliable. But what they aren't is if your tests pass, your confidence that like your code still works, that is not there, right? Because they're testing pieces of the code. They're not robust. So you don't have that faith, right? Like that's a really wonderful feeling. I was working with my co-founder at teaching kids programming, and we did everything test driven, but mainly because I was very, very firm on that we will be doing this test driven. She was not as sold on the idea, but she was willing to do it, and we paired together, and so it's all good. And we were on a very popular .NET podcast, and when that podcast was opened up, that very day, the system we wrote it on re-released, and it just broke everything. So we got a whole bunch of messages being like, I downloaded this and it didn't work. And so we're like, oh no. So we downloaded it and we ran our tests, and like 75% of our tests broke. And within 2 hours, we were able to fix all of it and re-release. And that was the day that she was like, oh, these tests, these are a good thing, right? You'll talk to people who are very adamant about the value of tests. And they all seem to have a story that was somewhere these tests really saved them, right? They're like, I survived this because of tests, and that's why I want to make sure I have them in the future. And so a lot of times at companies, you don't have that. You just sort of have tests because people have been told to write tests. And so you don't really have this safety net that you can rely on. And so the way that I usually tackle this is I don't, right? So Arlo Belshi, who's an amazing coach, has come up with this whole concept of provable refactorings, right? And like the shorthand is like, take a look at your editor and look at what their automated refactorings are. Those are usually pretty solid. Now it would depend on your editor and your language, right? But like if you're in IntelliJ in Java, if you do a rename or an extract method or an inline, like that is really solid. And it's solid enough that you don't really need a unit test. You can take some code, just do an automated refactoring and commit it. And that single commit, you could push to production without running your tests. And so maybe you could do 2 of those in a row. Like I have done 3 weeks of only doing automated refactorings to clean up code. And so I can push that entire branch without having to worry about the fact that I don't have tests. And very often by using these automated refactorings, I can get to a place where the code starts to become easy to test. Usually what that looks like is you extract some sort of method and you notice all the variables that are used in this method are passed into the method. And the only thing the method does is produce a result that is passed out, right? So you have this sort of accidental pure function where it's like all inputs in, all outputs out, no side effects. That's a very easy thing to test. Sometimes I'll have to make it like public so I can call it directly, or even public and static so I can call it very easy because it might be very hard to construct that object. But now I have this very easy to test piece. And then over time, I'll get like, a few of these easy to test pieces. So now I have like sections of the code that I feel confident. I don't feel confident about the code in general, but I feel confident about this one section. And then we can pull out something that's almost a pure function. If we just tweak it a little bit, we can make it a pure function. And so over time, you build that into these complex systems. And, these complex systems didn't just appear one day. They've been grown and built over decades. The way you get rid of them is, you slowly clean them up over years. If you could write code that bad for years and years and years, and then bring someone in and like 2 days later it was cleaned up, that's the way you should write code. If it was that easy to clean up, just go ahead, write a whole bunch of debt and then, call in somebody and have it disappear tomorrow. Unfortunately, that's not the way it works, which is why you shouldn't write code that way.
Yeah, and one of the things that we see that those test suits end up taking a lot of time to run.
And write, maintain. Yeah, like there's a lot of cost.
Yeah, and potentially that's something that should be measured. There are tests that haven't failed maybe for years. And potentially, 35% of the test suite hasn't failed.
There's two parts of that are interesting. The first is like, what do we do with the parts that don't change, right? So like, I was working at this company, this back in 2010. Most of it was written in visualbasic.net. Visualbasic.net is not a great language. And unfortunately, like, I don't think companies think about the impact of, if I choose this language, not just what is the language, but what is like the culture around the language, right? Like, back in like the early 2000s, when Java decided not to bring lambdas in, they were like, well, most people who program in Java don't use lambdas. We don't really need them right now. But what they missed is like, everybody who's innovating Java cares about lambdas. And when we couldn't do that stuff in Java, like, we left. There's a whole bunch of people who went to Ruby in particular, and all of a sudden all this innovation started occurring in the Ruby community. Some of them went to Scala, some of them went to .NET. But either way, like, we lost a lot of really valuable people because those were the people who cared about lambdas. Not the vast majority of the people, but a very important segment. And so like, when you choose VB, you get like your average VB programmer. Like, your average C++ programmer is both smarter and more dangerous than like your average Java programmer, right? There's a culture that you're getting into. And so VB had a lot of these issues. So we started moving them off of VB and into C#, which was really easy to do because .NET plays really nicely with .NET. I'm a coach, so I did this for like a month or two, and then I left. And I remember calling back and checking in with people like a year or two later. And I was sort of like, yeah, how much VB do you have left? And I'm thinking, like, they probably got rid of all the VB. And Jason was like, no, we got like 80% of the code base is still VB. And I was like, oh, I was really sad to hear that, right? Because I really thought like they're going to get out. And I'm like, well, how often are you in the VB each month? And he's like, oh, maybe 2 to 3 hours a month. And I was like, oh, now I'm happy. I'm like, okay, yeah, that makes total sense. Like, it's working, don't touch it. And so when you have like tests that are never failing, that's probably because the code is never being touched. And if that's the case, yay. Maybe you can section it off into like an entire component that sort of doesn't need to be touched. If you don't have to touch it, then it's really not a problem. Now, if you look at stuff like continuous test runners, they'll actually pay attention to like this section of code hit these branches of your tests, and I'll only run the tests that like it's changing, or some continuous integration or continuous test runners, they'll run all the tests anyways, but they'll start with the tests that are most likely to fail. That's a good thing. The second thing that you're talking about is like, what is the cost of a long cycle, like a long feedback cycle? And tests are part of that feedback cycle. Like, to me, compiling and testing is sort of like the same operation. Like in JavaScript, they're literally the same operation because there is no compile state. So like the way you know your test still actually works is you run the test. In like structured language like Java or .NET, you get that compilation, usually instantaneous, right? Because your editor is doing it. And then your test actually tell you not only, like if it doesn't compile, it doesn't work, obviously. But if it does compile, that does not mean it works. So you still have that sort of like test run cycle. When that cycle gets big, there's a whole bunch of destruction that occurs. And it usually happens silently. So like before the pandemic, when we meet in person, which I miss a lot, one of the neat things about doing mob or ensemble programming is that, you know, just a group of people hanging around a monitor is interesting, right? You're like, oh, what are you guys all looking at? And so people would just sort of walking by would end up joining the mob. And that's a very nice thing. One of the things that we don't often talk about, but mob programming is just fun, right? So again, like when people are laughing and having fun at work, that also attracts other people. Like, oh, what's going on here? So we had a manager join us. You know, he managed the entire floor, but he never actually sat with the team and saw what they did. And he was doing it just because he was like curious. Like, oh. And so he's like, why are they waiting so much? And I was like, oh, the build system is really complicated. So, you know, it takes a lot of time. And he's like, why has no one ever told me about this? And I was like, oh, no, well, they have. That's why they want to move to Maven, right? Because they had like a custom Ant script. And like, but there hasn't been like the push to get them to Maven. And he's like, well, how much time is it costing this team? And I like just sort of did a back of the envelope thing. I'm like, probably costing you about $150,000 a year in waiting for compilation. But for the entire floor, it's costing you about 2.4 million. And so when I showed up to the office the next time, I work in these sort of 2-week blocks and they go away from like 4 to 6 weeks and they come back. They were on Maven. Like, because now it's shared pain. And so a lot of times the pain of waiting, if it's individual, you're annoyed with it, but it's just the way it is. When you get this together in a group, you're like, oh my God, this sucks so much. When 5 people are sitting around waiting for a compilation or a test run that takes 10 minutes, that is so much more painful than when you do it. Because when you do it, you're like, okay, whatever. I'll open up my email. I'll surf Reddit. It's compiling. I've got time to play. But when you're doing it in a group, like that pain becomes very noticeable. And also, when I'm usually writing code in like a nice TDD fashion, I will run my test 3 times a minute, right? That means I'm doing 20 seconds of coding before I get feedback as to whether or not it worked. I am not going to do 20 seconds of work and then wait 10 minutes. At the end of the day, I'll accomplish like 3.5 minutes worth of work. Like I will get fired very quickly because I've not achieved anything. I catch myself sometimes in this, like very often it's like bug patching, right? Where it's like, oh, I just did something on a phone app and there's a little bug. It's obviously like one line. So I'll be like, oh, well, I'll change that line and then I'll redeploy it. And then all of a sudden I've done like 6 little changes and it's taking me like 2 hours. I've learned to catch myself and be like, by the 3rd time I've done that, I'm like, nope, we have to change. Pay attention to the cycle time, right? I still have this sort of hubris of like, I'll get it right the first time, right? But at least now I'm aware that if I haven't gotten it right on the 3rd time, I need to up my discipline.
Microservices architecture is all the rage these days. But do you know what it really means and how to implement it to empower your teams to make the best decision for the problem at hand? On the Semaphore blog, you can learn about microservices and how to take advantage of features like test reports, monorepo, and Docker support to build, test, and deploy your microservice application at scale. Head over to semaphoreCI.com/blog for more information. and happy reading.
You gave us some hints in terms of how you work and help people and coach. Can you give us like maybe a more concrete example that would work with some typical company, whatever that would mean, or team that you would work with? A lot of what you're saying like sounds very interesting and attractive, and the way that you would organize that.
There's a couple like core principles that have really helped me. Early on, I used to do a lot of rescue projects. And the thing I love about rescue projects is people are in extreme pain. And when you're in extreme pain, you're just willing to try new things. A lot of the things I do are not what companies are used to. So it was really nice to have willing companies. They're like, you want to add CI? Go for it. We need help. Do whatever you need to do. I really liked that, but I found that very often it was very short term wins. I would get a company out of extreme pain, and then I'd turn around and a year or two later, they'd undone these practices because they're no longer in extreme pain. So they sort of revert to their previous behavior. And so what I would end up doing is Arlo Belshi again sort of gave me this model, which is really helpful, where he said, stop measuring what you do. Only pay attention to what has happened when you're not there. So instead of looking at a team and saying, what can we do? How good can we be? I will look at the team and I will say, what can I improve with them so that when I'm gone, they continue to do it? That really changes the math. Like in both situations, I want to win, but now I want to win by figuring out what they will do. And that means I do a lot less. So if you're like, oh, they're not ready to write tests, but they are ready to start like extracting methods, well, then let's just extract a method. Or if they're willing to write tests, but all their tests are really long, maybe I can make them a little bit shorter. Or we're deploying every 4 weeks. I want them to get to 1 day, but maybe I can get them to like 3 weeks, deploying every 3 weeks. And then when that's done, I can get them to deploy every like 2 weeks. And then when that's done, I can talk about every 1 week. So it's like, how do I make these small incremental changes with your team? When you start measuring that, your behavior will change significantly because you'll no longer do what you think is right. You'll do what they are ready to accept. Like you're moving them to a better place. You've given up on moving them to the good place. So when I sit with the mob, like we all join around the same computer. I'm remembering a time when I did this out in Miami, and I had one person, Tony, who just wasn't having it. So I was like, okay, but you have to be in the room. Like you don't have to participate, but you have to be in the room. So we'd all get together and we'd program on their system. And this is in a Java system. And so this next day, he's sort of like, well, I'll join, but I'm not going to take the keyboard. And so I was like, okay, so that's progress, right? Like that's a little bit different. So we let him join, but not take the keyboard. And the next day he was like, okay, I'll take the keyboard, but nobody's allowed to tell me shortcuts. none of the shortcut keys. And we're like, okay. And so like that's progress, right? And then again, like just a little bit of progress every day ends up becoming this mountain of change at the end of the year. And so this idea of just slow change that they will continue. And like they actually called me a month later when they're like, at stand up, Tony was like, we should mob on this. That's change that's persisting without you. And so like that's the core of my coaching style now, is not to worry about what we're doing in the moment, but pay attention to the team and move them a little bit towards the direction you want. And then just be patient. Now, patience is extremely hard for me. It's not my strong suit, but something that helps is I only work 2 hours a day with each team. So they can move slower and I don't have to be part of the waiting. And then the other thing that helps is I go 2 weeks at a time, which is sort of enough to establish a behavior. And then I go away for 4 to 6 weeks. And that also gives me time to be patient. They might need a month to internalize this. They can have that without me sitting there chomping at the bit, being like, haven't you gotten this yet? Haven't you gotten this yet? So that's like a lot of how I end up moving companies. And, slow but steady is a very powerful change agent.
Yeah. And you mentioned 4 to 6 weeks, and then you come back. So that's kind of a cycle.
Yeah.
I mean, what's the average number of cycles that you would do with the team?
Average number is like a hard thing. Usually the way it works is I go until something in the company changes. Usually it's like a CEO. Like the CEO changes, and then like as a consultant, like there's a lot of things that aren't there. But the basic idea is like, as long as things are going well and they're making progress, they just want more of it. But in terms of like useful timelines to this equation, it's usually around a year to a year and a half before the team starts making noticeable improvements while I'm gone. Right? So in the beginning, the thing that I'm looking for when I come back is like, hey, the stuff we were doing when I left, are they still doing it? And I am judging success based on, yes, 4 weeks later, they're still doing the stuff. They haven't backslid. Like 18 months later, I'm looking for, when I come back, what's the things they've improved on their own while I'm gone? I've had teams that have done it like in a year. That's very quick for a team to occur, but it does happen. That's great. Everything they can improve without me is good, right? Because then I can give them the stuff they can do without me. You get more interesting things. But one of the things I love about this industry is like every year I have a list of things I should be learning, and every year that list only gets bigger, right? Like more things get added to it than I can take off, right? So it's such a great place to continue to grow and learn. There's always new stuff. There's always better stuff. I have a saying of like, if the code you wrote last year doesn't embarrass you, what have you learned?
I do have one more question that I want to ask. I've been seeing that pattern quite a lot. We talked about like a legacy application that has been around for a while with all the good and bad attributes it has. The one pattern that reaches me more frequently by the nature of my job, a team starts using SAM for their team of 15 people. They created something that is making value for people. It's recognized, they're starting to grow. 18 months to 2 years later, they are a team not of 15 people anymore, but maybe 150 people, 200 people. And they inherited that application that was developed by developers that were maybe great, maybe just good enough to get through that stage. And then they're reaching some other stage, and some more experienced people are coming in, and so on. So that moment of culture, of like changing the culture, maintaining the culture with expanding the team on such a rapid scale.
It's so hard. I mean, my basic advice is don't do that. But in terms of how to actually follow that advice, 38 Singles has this thing where it's like, only expand the team on extreme pain. Like if I'm a manager and I manage 4 people, I'm obviously not as valuable as another manager who manages 500 people. And so managers have this sort of perverse incentive to have more people better. That's really unfortunate. I feel like if every person the manager didn't hire, that salary went to the manager, they'd be like, how can I get my team as lean as possible, right? But in a very real sense, every person a CEO or an owner of a company doesn't hire is money that goes to their pocket. So like figuring out like, how do I keep my team small is a great value. And one of the things I think that's just amazing about mob programming is you reduce like a team of 6 entities to a team of 1 entity, the mob. And the overhead of managing a single entity is so much less than the overhead of managing, like with 6 people, 6 people who can talk to 5 other people, it's 30 connections. It's crazy. And very quickly, these numbers just become logarithmically high. And there are so many people at companies right now who what they do, what their job is, not like what their job title is, definitely not what their job description is, but if you sit with them all day, what their job is to attend meetings, not to actually do work. There's some people that's all they do all week is just attend meetings because the overhead of coordination has gotten so high. And that's now normalized. Like large companies, like, oh yeah, 40 hours a week in meetings, that's my week. And there's a downside that sometimes it actually feels like you're doing work, right? Because sometimes planning to do something can give you the same dopamine rush of accomplishment of actually doing it, which is another dangerous part of the way like human brains work. So try to grow slower. And a good way to do that is to mob or at least pair, because you get more out of your pair, right? Like your pair will produce more and therefore you have less need to bring in another person. And sometimes that looks so trivial. I was at a company and we're mobbing again because it's fun. The artist decided to join the mob. And we were working on something where there's an icon that he had drawn, right? That we had to add to the site. And we added it and it was the wrong size. And the programmers are like, oh yeah, no problem. Let's just change the size value. And he was like offended, right? Like he was like, what have you done to my beautiful icon? We're like, it's the right size now. And he's like, no. He whips out his computer, which had Photoshop on it. Not only did we not know how to use Photoshop, like we did not have Photoshop to open. And he immediately changed it and sends it to us and we just put it in and now everything is beautiful. And it's like a 5-minute conversation, but the way that worked like last week when he wasn't in the mob is we resized it and then it went to testing and maybe they caught it, maybe they didn't. If they did, it would have come back to us. If they didn't, it would probably get caught at some point and it would come back into our grooming session where we would talk about, well, is it the most important thing to like make this icon a little more pretty? And then if it did, we would like budget it. And he said, like, I mean, we were like months to fix this thing that's like 5 minutes when he's sitting with us. And so Taichi Ono has the saying, movement is not work. So often at companies, when you have like 150 people, everybody's busy, but they're not productive. You've increased your busyness, but you haven't increased your productivity. So like try to keep your teams as small as possible, keep them as independent as possible, keep your company as small as possible. These are all good things to do. The second part of like, how do you grow a culture? Like if you had 11 people, that's the culture. If you have 150 people, that 11 people is like not enough to make a culture, right? So how do you spread that culture? And that's hard, right? Because people are coming there with their own culture. And I think that's why you see so many big company cultures looking kind of like the same mess. Because like that's what people are used to. And when you grow that much, you're like, yeah, well, that's what you get. So growing it slow enough that you've renormalized. And so I mentioned sort of like that 4 to 6 weeks with the team to let them renormalize. I think there's a similar thing, like mob with your team. So there is a unique culture, but then bring someone in and really give it time to like, it's like when you buy fish, you don't just dump them in your tank. That kills fish. You put them in a bag in water and you let everything renormalize. And you really have to pay attention to that or you end up with just a different system. And that's hard to do when there's pressures and everyone's like, go, go, go and grow. But it's really costly if you don't. Like taking the time to grow slowly, bring people in and have them like adopt a new culture and then grow again so you can keep that culture. That's really important. And going from 15 to 150, you basically can't do it. I've seen a lot of trouble with people going from like 8 to 30. At 100, you've lost that battle. So you need to really just slow down and pay attention to keeping your culture if it's a culture you care about.
Yeah. That period when you would just stop for a moment sounds like pretty powerful. Because usually there are those like hiring quotas that I hear about, and then it's kind of monthly or quarterly hiring quota.
Yeah. The reverse of that is like when a company is like, oh, we're going to fire 15%. No part of me does that make sense, right? Because if you can just randomly fire 15 people, like there's something wrong with how you're paying attention to people. A, you grew too fast. You shouldn't have 15% that you can cut. And B, when people do that, they lose a lot of the best 15% of their company. It's not like they're trimming the worst 15% because There's a lot of voluntary people who are like, well, I'm good, so I can get another job. Let me get out of here. And so you lose a lot of really good people. It's really hard to fire people. Like, it's emotionally hard. Most people get fired not because of incompetence, but because they pissed somebody off. I've been fired before. It was because I pissed people off. Like, I remember at MCI, this is way before I was a coach, going to my team lead, my boss, and he's like, it's really important here that you fit in. And I was like, yeah, but the thing you're doing won't work. Like, if I do it and it works, isn't that more important? And he was like, no, it's more important that you fit in. And I remember going back to my cube and being like, oh, well, I'm screwed. Because even knowing that what I'm doing will work and will save the project isn't enough to keep my job. And with that knowledge, I still want to do the right thing. Like, I know what the right answer is to keep the job, and I don't want to do that. I'm in trouble. Woody has a saying where it's like, most people have optimized their job to be the least miserable for them each day.
That's not a very good metric to follow.
No, but it is what people do.
Yeah. I wanted for the end to touch upon one of your projects, Teaching Kids to Code. Is that the title?
Yeah, Teaching Kids Programming. So Teaching Kids Programming is a charity I co-founded with Lynn Langett back in 2010. It's still there. I'm no longer directly involved with that one, but you can find it at teachingkidsprogramming.org. I also have just a lot of learning stuff, both for kids and adults, on my GitHub, Learn with Lou. But yeah, if you have a young child, first of all, teach them to code, because whether they're a programmer or not, being able to code is almost like a class hierarchy nowadays. Like, you're going to use technology no matter what. But are you just going to consume technology, or are you going to be a creator of technology? Those are very, very different things. And no matter what you do, whether you're a programmer or not, you will need to be able to understand how to create technology. There's a saying where it's like, not everyone needs to be a programmer in the same way as not everyone needs to be an author, but everyone needs to know how to read and write. And coding right now is part of reading and writing. In fact, Felina out of the Netherlands has been doing some really neat stuff with code reading clubs, where all they do is read code, right? Because that's how you learn to read and write English or whatever your native language is. So they've been looking at like how you teach native languages and trying to take those practices back. And so just being able to read code makes a big difference. I've done a lot with the testing community, and I've spoken to a tester, and she was like, when I started, I was really afraid to read the code. And now I realize if I read the code and I don't understand it, the problem isn't that I'm not good enough at code. Like, the problem is that code was not written well. And that's the section I need to test the most. And so, like, being able to read and write code is important, even if you never become like a professional programmer. And if you can't, people will bullshit you. They'll just start talking tech so that you go away, because like, we don't want to deal with you today. Oh, well, with Kubernetes, when you deploy a cluster, oh yeah, that person's gone. So like, you need to know enough that you can like listen and be part of the conversation. If you don't teach your kids that, they won't be, whether or not they end up writing code for a living or not. Just knowing what is possible, knowing what that looks like, is really, really valuable. So Teaching Kids Programming does it mainly in Java, which you would think like, why is Java such a great language? And Java isn't. That's not the way I would like to think of it, right? Like, if you're going to write in Notepad, write in Python. It's really good for Notepad, but don't teach your kid to write in Notepad. That's a disservice, right? Like, use a proper editor. And Java and IntelliJ is a very nice, it gives you autocomplete. All of a sudden things become multiple choice, and it gives you corrections. And there's so much tools. We don't teach how to write a new method usually to like lesson 18. We write code and then we extract the method. That's really easy to do. But if you extract a method using an automated refactoring, you don't have to know like what a method signature looks like. You just have to recognize it. You don't have to be able to write it. So yeah, Teaching Kids Programming is really good. It works sort of in 5 stages, right? So there's a part in the very beginning where you have a recipe. So it's like, here's the English, turn it into code. And it's just like doing like a Lego project, right? Where it's like, here's the stuff. We don't tell you what the code looks like, but we know what each step has to be. And it's written in such a way that each line you can run it and see, did I get it right or not? That feedback cycle feels very like TDD, except for it's not automated. Then we have like a recap where we sort of like point out pieces. That's usually a video format. It's really short. And then we have a variation section where we say, okay, well, we have this code. What happens if we tweak this variable? What happens if we tweak? And it's more hacking, but it starts to show, because a very simple program has so much differences when you can just change a couple values and the program looks completely different. And then we have quizzes, which are basically unit tests, but fun. They're like fun enough that like on our evaluations, kids will be like, my favorite parts were lunch and the quizzes. When quizzes are as good as food, like that's because the way schools traditionally do quizzes is, I want to figure out what you don't understand so I can grade you. That is not how we do quizzes. We do quizzes to say, I want you to realize that you can now do something that you couldn't do when you started. We want you to realize what you've learned. It's like in that old movie Karate Kid where he's painting the fence for like 3 days and Mr. Miyagi like shows him to block the punches and he's like, oh, I can do this now. Like I didn't realize I could do it, because learning and realizing you learned is something different. So the quizzes, the kids always pass them. And then when they leave, what they take away is, I can do something I couldn't do before. That's really a good feeling. And then we have homework, which is like koans. If you've ever done like the Ruby koans from Edge Case, which are just amazing, which are just little unit tests with a little blank, and filling in the blank helps you see so much more of this very rich tapestry that we're in. And so those are sort of the 5 points, and they go together. They're meant to be not self-taught, but led by a teacher. But like, hey, if you're listening to this podcast, you know how to code, and you can just take it and teach your kid to code in the same way you do. It's such a great thing. And even if you don't want to do that, I mentioned like I created strong style programming. Strong style programming is just basically the person at the keyboard is not doing the thinking. They're doing the typing. Just have your kid type for you a little bit. It's time you get to spend with your kid. They get to see what you do. They don't have to really understand it that much either. Take them for like a half hour a day, have them type for you. They'll get an appreciation with you. They will absorb so much. Don't worry about explaining what you're doing. Just, start with the keystrokes. And when they get the keystrokes, you can give them the words. When they get the words, you can give them the concepts. It's a really valuable thing. And having your kid understand what you do is a really nice feeling. So often we are not appreciated because we're not understood.
Yeah, I can relate to that. Yeah. Well, thank you so much. It was an amazing conversation. I feel that we could end up being that format of a podcast that could take 2 or 3 hours, but maybe we could do another iteration. Again, thank you for everything. It was great talking to you. And yeah, we actually made a plan in the beginning that we are going to share show notes.
Yeah, link of all the show notes will be in the description of this podcast. It'll take you to a GitHub page, just a markdown of all the links of the stuff. So if you're like, what was he talking about? They'll give you a chance.
Yeah, great. Thank you again.